Right, so Bismillah ar-Rahman ar-Rahim. Any questions before we start? Any questions before we start? Can you hear me?
Yes, sir.
Okay. Okay, so let's begin. Just an announcement, we shall have a quiz, inshallah, this weekend, a small one, based upon what we've covered so far in chapter number 3 on the transport layer. So in the last lecture, we progressively built this protocol, and we said that if you are to provision for reliable transport services end to end. So notice that आपके पास you've got this process running on your end machines, and what this has to do is it has to ensure that you have reliable delivery of a file across multiple hops across the entire world, maybe across the internet, and the transport layer has to ensure that you have reliable delivery. Now for that, we said that, okay, let's first of all assume that you have a channel which is perfect. So you have no bit errors when a packet traverses this channel, and you have no loss when a packet traverses this channel. So if you have no bit errors and no loss, phir to koi masla nahi hai, because you know whatever you transmit is going to be received exactly as you've transmitted, no bit errors, and raste mein wo gumega bhi nahi. So then, of course, you can have a very simple protocol. Simply transmit something, and when you receive that, you deliver that to the higher layers, and you're sure that you don't need to number things, you don't need to check ke packet theek pahuncha hai ki nahi pahuncha. If your channel corrupts bits but does not lose them, so then the question is that how do you detect that your packet is correct or incorrect? Okay, so that's the first question. How do you detect whether your packet is correct or incorrect? And uske liye, what reliability mechanism does one build in? One has to build in a mechanism such as, anybody? जी बताएं. If your packets can get corrupted, packets can have bit errors. Okay? So the first question is, how do you detect bit errors?
Sir, we could like put in a string or whatever ourselves into packet, and we can see if the string is same at the end.
So string same hai ki nahi? Like, how do you know it's the same string? So somebody said
so
parity
we could
bit.
pre-decide that.
हाँ, लेकिन parity bit तो एक extra bit है जो कि odd या even number के लिहाज से आप set करते हैं, right? So if you have, let's say, a single byte to transmit or a word to transmit, you can add an additional bit, ठीक है, which is either a 0 or a 1, depending upon what this word is. But typically in a packet, you'll have multiple bytes, ठीक है, it'll be hundreds of bytes long. तो उसमें there are a bit more sophisticated techniques for doing that using coding theory. And one technique is to use something called a a checksum. Okay. So basically, what is a checksum? A checksum is an algorithm which calculates a specific number based upon the contents of a packet. So it could be that you break up the packet into 16-bit words, add up all the words, ठीक है, and जो भी आपके पास sum आएगा, ठीक है, उसको आप let's say invert कर देते हैं, ones को zeros कर देते हैं, zeros को ones कर देते हैं, and you get a checksum. Now that checksum you include in the header and you transmit that particular packet. Now when the receiver receives that packet, it uses the same algorithm to independently create that checksum. Okay? And then it compares जो उसने create किया and what has been transmitted along with the packet. It compares the two. If the two are equal, it knows that the packet has arrived correct. If the two are not equal, it knows that some bit has been flipped along the way. ठीक है जी? So is this clear? Checksum.
So what if the checksum also gets like
now इसमें we have an assumption. I mean, if the checksum gets corrupted, that's a very good point. Then of course there is no way that then of course आपको लगेगा कि ये packet corrupt है, whereas it's not corrupt. But उसमें what we do is that we rely on the assumption that the probability of a bit error is very small. Okay, let's say 10 to the power minus 4, 10 to the power minus 5, minus 6, some very small number, 1 in a million, 1 in 100 million. That's the kind of probabilities that we're assuming. So then for multiple bits to get corrupted, the probability of that event becomes even smaller. And then for them to get corrupted in such a manner कि सिर्फ checksum corrupt हो और बाकी चीज corrupt ना हो, इसकी probability of that event is even smaller. ठीक है? So it is possible that you could have errors such that the checksum still remains correct. You could have errors in the checksum such that the checksum error and the corruption error still match up. ठीक है? Those are all probable events, but with very low probability. So अगर एक आध bit भी आपका corrupt होता है या 2-4 bits corrupt होते हैं, तो typically your checksum will not be correct. ठीक है? So you will know that there's been a problem. You will simply ignore that packet. ठीक है जी? Any questions here, checksum में? So checksum is a mechanism to detect errors. That's a key technique that you're going to use, because notice that you're sitting as a receiver, you don't know what happened to the packet along the way. ठीक है? आपके पास एक पैकेट पहुंच गया. अब आपने चेक करना है, हाँ जी ये पैकेट ठीक है या नहीं. So as long as you know what is the method of creating the checksum, you create the checksum independently and then compare it with what has been transmitted along with the packet. If the two match up, packet ठीक है. If the two don't match up, then you know कुछ गड़बड़ हुई है along the way and you simply discard that particular packet. Okay? Any questions here? Checksum के बारे में. So checksum is for detecting an error. Okay? Now, so that's an additional thing that you have to do if your channel can cause bit errors. Then if the packet is received correctly, you then have to tell the sender, because the sender would not know कि अच्छा packet ठीक पहुंचा कि नहीं पहुंचा. ठीक है? So उसके लिए what do? You send what you call acknowledgements. ठीक है? So acknowledgements क्यों जरूरी है कि जी अच्छा पैकेट ठीक पहुंचा या नहीं पहुंचा. अगर पैकेट ठीक पहुंचा तो receiver will send back an acknowledgement to the sender. If the sender receives the acknowledgement, it knows कि पैकेट ठीक पहुंचा. अगर पैकेट corrupt है, ठीक है? So then what the receiver will do is it's going to send back maybe a negative acknowledgement, a NAK. That's one way of doing things. ठीक है? Then the question is, अच्छा अगर ये ACK खराब हो जाए, if the ACK gets corrupted, फिर आप क्या करेंगे? Well, if the ACK gets corrupted, then एक तो ये है कि you're assuming that the ACK is small in size. The probability of that event happening is small. You could do that. But still, that doesn't guarantee that the ACK can't get corrupted. So maybe you need to then send a checksum along with the ACK as well. ठीक है? So ACKs के साथ भी आप checksum भेज सकते हैं, NAKs के साथ भी आप checksum भेज सकते हैं. ठीक है? So that will ensure that your ACK has been received correctly at the sender. Okay. Now, what you can also do is that if you think carefully, ACKS and NACKS, अगर आप ACKS के साथ एक sequence number लगा देते हैं, then you might not need to have both ACKS and NACKS, because if you said, if a packet got through correctly, you say अच्छा ये acknowledge आपने कर दिया वो packet number. If it didn't get through correctly, आप previous जो सही पहुंचा है उसका ACK भेज दें ताकि सेंडर को पता चले कि अच्छा ये पिछला वाला सही पहुंच गया था, ठीक है. सो इट नोज कि अच्छा मैंने तो अगला भेज दिया था लेकिन ये तो पिछले वाले को ही एक्नॉलेज कर रहा है, इसका मतलब है जो नया भेजा है वो ठीक नहीं पहुंचा. सो देन if you use sequence numbers along with ACKS, then you don't need to have ACKS and NACKS. ACKS with sequence numbers suffice, okay? And you can use 2 bits, a 0 and a 1. So an ACK with the sequence number 0 and an ACK with the sequence number 1 using an alternating bit protocol. ACK 0, ACK 1 karke, okay? Using a sequence number with ACKS, you can do away with having negative acknowledgements. Okay. So checksums, detecting errors. ACKS tell the sender that the receiver has correctly received a packet. NACKS tell it कि नहीं हुआ. अगर आप ACKS के साथ sequence numbers भी इस्तेमाल कर लें, तो then of course it knows that what packet has been received correctly. You also have to use sequence number with the packets themselves so that the receiver knows कि अच्छा ये कौन सा packet है. If you are retransmitting a packet, ठीक है, then of course it will be able to detect अच्छा ये नया packet है या पुराना packet है. So using just 2 bits, a 0 and a 1, the receiver can discern whether this is a new packet or an old packet. ठीक है. So notice we're adding complexity in the protocol to cater for different scenarios. Checksums to detect errors, ACKS, NACKS, or ACKS with sequence numbers to detect whether or not the receiver has correctly received the packet. Sequence numbers with packets, a sequence number 0 or 1, so that the packets can be numbered and the receiver can know कि अच्छा ये नया packet है या पुराना packet है जो कि आपने भेजा है. So just using 2 bits, a 0 and a 1, will work because that's all you require in a stop and wait kind of a scenario. Okay. But the problem with the stop and wait scenario, as we discussed last time, is that it is very, very it is very inefficient. Now, why is it inefficient? Because आपने एक packet भेजा and जब तक उसका response नहीं वापस आया, basically the channel is empty. It's not being utilized. So you have bandwidth available, but you're only using the channel for a fraction of the time. So you're only using it for this particular transmission time over this round trip time, which could be very, very inefficient. So what do you do then? How do you sort of make this more efficient? G. Any ideas, any thoughts? How are you going to make this efficient? Efficiency कैसे बढ़ाएं? Yeah, very good. Send packets continuously. Okay. So basically, now what you need to do is that even if a packet is not yet acknowledged, आप अगला packet भेज देते हैं and अगला packet भेज देते हैं. So basically what you're doing is you are sending a window of packets. Now, why a window? Because if you kept on sending them continuously without worrying about कौन सा acknowledge हुआ, कौन सा नहीं हुआ, then you can't be sure कि is the receiver correctly receiving what you are transmitting or not. So what you do is you send packets continuously. Okay? We shouldn't say simultaneously because you can't send them simultaneously. You can send them one after the other. So you're sending them continuously so that ये जो आपका channel है, that remains full. The sender keeps busy all the time, and you keep on sending packets until you get back the first acknowledgement. So you have what you call a window. Okay? So you're allowed to send, rather than sending one packet and receiving one acknowledgement, now you're sending a window of packets, and then you're getting back these acknowledgements. And each time you get back an acknowledgement that gives you confidence that ye packet theek pahunch gaya, and it sort of gives you credit, and then you can transmit more packets. Okay? So the question then is that, do we have any generic forms of a pipeline protocol? This is called pipelining, where you're allowed to send multiple packets one after the other, which are in flight, which means that they are yet to be acknowledged. Okay? So isme we have two protocols, which are generic protocols. One is called a go back N, and the other one is called a selective repeat protocol. Okay? A go back N, selective repeat. Okay? And what that does is basically it increases the utilization, because now what you're doing is you're transmitting multiple packets, and uske baad aapko acknowledgement jab aati hai, then that gives you permission to transmit more packets, and that increases your utilization. Okay? So whenever you have pipeline protocols, the question is that how many packets can remain outstanding without being acknowledged, and that is determined by what you call the window size. Okay? So Ali has a question here that how do we decide on the window size? Well, you could be conservative, okay, and decide on a window size jo ke chota hai, or you could allow for more packets to be transmitted. Okay? So if you want continuous operation, okay, so uske liye you need to choose a window size such that जितना आपका राउंड ट्रिप ट्रांसमिशन टाइम है उसमें आप कंटिन्यूअसली पैकेट्स भेजते जाएं. So if you divide your round trip transmission time, ठीक है, by your transmission time, that would give you okay to fill this round trip time. How many packets can you send before you get back your first acknowledgement? You can work that out. ठीक है, round trip transmission time को अगर आप divide कर दें by your transmission time, ठीक है, 1 minus that would give you some estimate of कितने packets आप continuously भेज सकते हैं before in order to sort of work at 100% channel utilization. Okay. Now notice कि यहाँ पे we've assumed you have a wire between the sender and receiver, बीच में multiple hops नहीं है. So this is the round trip transmission time is fixed. In reality, between the sender and receiver, you will have multiple repeaters, multiple routers, ठीक है, multiple hops, and आपके पास जो round trip transmission time है ये exactly fixed नहीं होगा. It will vary from packet to packet, ठीक है, and that adds another complexity into the system. And depending upon the congestion in the network, ठीक है, ये हो सकता है कि अगर congestion नहीं है तो RTT round trip transmission time बहुत थोड़ा है या कम है. Whereas if there is congestion in the network, then your round trip transmission time is going to become much larger. ठीक है. So if you have a long round trip transmission time और आप उसको continuously भरते जाएं, that might add fuel to the fire. ठीक है. It might increase the congestion in the network. ठीक है. So इसमें, I mean, a rule of thumb is that okay, if congestion नहीं है, round trip transmission time आपके पास है, so the number of packets required to fill up your round trip transmission time is a good first approximation to start from. And then of course you could then dynamically also change this window size based upon the conditions. That would be a more complex protocol. अगर statically fix करना है कि अच्छा ये fixed size की window हमने रखनी है, वो क्या होनी चाहिए? So your round trip transmission time divided by your transmission time for a packet would give you a good starting point. Okay? Any questions here? विंडो साइज तो आपके पास आ गया. अच्छा, उस विंडो साइज में आपने हर पैकेट को नंबर करना है. So the question then becomes is how many sequence numbers do you need? So when you number things, typically you're going to do that in bits. So if you have n bits, then you can have 2 to the power n combinations, and n bits के साथ आप उतने sequence numbers create कर सकते हैं. लेकिन the question is that if you have a certain window size, तो फिर आपको फिर भी how are you going to number your bits? Okay, so if I have a window size of 4, should I number my packets as 0, 1, 2, 3, and then go back to 0 again? Should I? So basically, you can think of this as wrapping around. Okay, so with a window size of 4, should I use numbering as 0, 1, 2, 3, or should I use 0, 1, 2, 3, 4, 5, 6, 7, and then come back to 0 again, or should I do something else? Okay? And yeah, we will look at different use cases to understand कि अच्छा 0, 1, 2, 3 अगर 4 विंडो साइज है तो 0, 1, 2, 3 से 0 वापस आने में कोई नुकसान है या नहीं है? Will that work or not? Do we have to have a longer sequence, ठीक है, for numbering these packets, or is there any relationship between the window size and how we should wrap around these sequence numbers? इसमें कुछ मसले हैं या नहीं है? We will come to that in a minute. Okay. So if you were to use an alternating bit protocol such as 0 and 1, ठीक है, would that be sufficient to use 0 and 1 in when you have a window? Let's say you have a window of 4. Can I use 0 and 1 as my packet numbers? G. So if you have a window size of 4, okay, so can I use 0 and 1? And the answer by Aisha Rafi tells us no. Why not? G, why not?
Because 4 packets need the 4 different numbers to identify them.
Yeah, so very good. You need to have distinct sequence numbers. Okay? Otherwise, you will not be able to distinguish between these packets. You would not be able to discern between these packets. So if you have a window size of 4, at least आपको 4 unique numbers तो चाहिए उनको distinguish करने के लिए. 0, 1, 2, 3 maybe. Or let's say if you count from 1, 1, 2, 3, 4 maybe. But then the question is that sufficient? Okay, we'll get to that in a minute. Okay. Now, the basic principle over here is that you can't have 2 outstanding packets with the same sequence number. Okay. So you need to have distinct sequence numbers, and you also need to worry about buffering requirements at the sender and the receiver. Now, what do we mean by buffering requirements? Basically, आपने एक पैकेट भेजा at the sender. जब तक उसकी acknowledgement वापस नहीं आएगी, you're not sure कि ये ठीक पहुंचा कि नहीं पहुंचा. So you will buffer that at the sender. ठीक है? Let's say that an acknowledgement does not come through. फिर आप क्या करेंगे? ठीक है? So basically, आप पैकेट भेजेंगे and एक reasonable amount of time के अंदर अगर acknowledgement नहीं आती, तो then you begin to worry कि यार ये पता नहीं पैकेट पहुंचा कि नहीं पहुंचा. तो आप कितना इंतजार करेंगे? So you will have to wait for some reasonable estimate कि इतने टाइम में पहुंच जाना चाहिए था. And अगर आपके पास ACK वापस नहीं आती, then you need to retransmit that packet. Okay, so you need to retransmit that packet if an ACK doesn't come within a certain time frame. Okay, so how do you do that? What mechanism do you require for that? Is you transmit a packet and then you start. Anybody? G. Very good. You start a timer. So you transmit a packet, start a timer. And if that timer times out, okay, so हर timer का एक certain timeout होगा कि इतने time के बाद it's going to raise the alarm कि it's timed out. If that timer times out and उतनी देर में आपको acknowledgement वापस नहीं आई, then you know कि अच्छा it's been too late. I need to retransmit my packet again. So that's why you need to buffer the packet at the sender. ठीक है? Now इसी तरह से रिसीवर के अंदर आपको एक पैकेट रिसीव हो गया, ठीक है, एंड आपने एक्नॉलेजमेंट भेज दी वापस, ठीक है, बट सपोज दिस पैकेट दैट यू रिसीव्ड वाज आउट ऑफ सीक्वेंस. सो देन because you are to deliver packets contiguously to the layer above, so you will wait for whatever packets are missing. And जब वो सारे एक सीक्वेंस में पूरे के पूरे पहुंच जाते हैं आपके पास, then you can transmit this data to the layer above in one go. ठीक है? So दो तरीके हो सकते हैं. एक तो ये कि अच्छा you're only waiting for a particular packet number. अगर वो आ जाता है तो ठीक है, अगर वो नहीं आता तो आप कहते हैं नहीं, मुझे बाकी कुछ चीज कबूल नहीं है, I will just drop those packets. That's one way of doing it. That is with a receiver window of size 1. If you have a receiver window which is multiple packets, let's say 4 packets की आपने receiver window बना दी, you can now expect any of those 4 packets. Let's say आपको packet 0 नहीं मिला, packet 1 नहीं मिला, and packet 2 मिल जाता है. Then you can buffer packet 2 and wait until you get packet 0 and 1. So now when you get 0, 1 and 2, 2 पहले से था आपके पास, 0 and 1 बाद में आए. Now you have 0, 1 and 2, all of them. You can send them up 0, 1 and 2 up continuously. इसको इकट्ठा करके you can send them up in one go up to the receiver. So the question is, how many times would you retransmit a packet after a timeout? So you would retransmit it once after a timeout. ठीक है? तो आपने पैकेट भेजा, टाइमर स्टार्ट कर दिया, जब तक एक्नॉलेजमेंट वापस नहीं आती, यू वेट. ठीक है? अगर एक आ जाती है बिफोर यू टाइम आउट, वेल एंड गुड, दैट कंफर्म्स दैट दैट पैकेट हैज बीन सक्सेसफुली रिसीव्ड एंड नाउ यू डोंट नीड टू वरी अबाउट दिस पैकेट, यू नीड टू मूव ऑन टू द नेक्स्ट पैकेट्स. ठीक है? So every packet that you send, you start a timer. Now the last or the packet which has the oldest outstanding timer is going to time out first. ठीक है? तो उसको आप पहले रीट्रांसमिट करें और एक ही पैकेट को रीट्रांसमिट करेंगे. ठीक है? एंड उसको रीट्रांसमिट करते रहेंगे until it's confirmed कि वो पैकेट नहीं पहुंचता. ठीक है? So you only retransmit a packet once on a timeout. ठीक है? And then you start the timer again, wait for its act to come through. If it comes through, you know it's gone through successfully. Otherwise, दोबारा time out होगा, दोबारा packet भेजेंगे. ठीक है? Let's say कि you're connected across a network जो कि it's broken. You send a packet, timer start किया, act वापस आया ही, time out हो गया. फिर भेजा, फिर timer start किया, फिर time out हो गया, फिर दोबारा भेजा. You might do that multiple times, and then if you didn't sort of stop after a certain number of times, you could end up in an infinite loop. So usually, let's say आप किस website को browse कर रहे हैं, आप उसका URL लिखते हैं, your client tries to connect with the server, it retries multiple times. ठीक है? उसके बाद at some stage, it might come up with a message at the higher layer, at the application layer, telling you कि sorry, connection जो है ना time out हो गया and you cannot connect to the server. And usually that happens because you've timed out multiple times at the transport layer before a message is sent up to a message is displayed to the user by the application layer. Okay, so any questions here? Now, there are two standard approaches, and one of them is called the go back N, and the second one is called selective repeat. Now, go back N, the key thing to remember is, आपके पास sending side पे you have a window of N packets which you can transmit. So that is that you can have up to N unacknowledged packets in the pipeline. Now, receiver sends cumulative ACK, and I'll explain what that means. It does not acknowledge a packet if there is a gap. You have a timer for the oldest unacknowledged packet. And when the timer expires, you transmit all unacknowledged packets. ठीक है जी? अब इसको समझने के लिए is a very nice, just want to check this. It's a nice applet which is associated with the website. ठीक है जी? Can you all see this? जी? Yes, okay. So इसमें अगर आप notice करें, ये at the top you have the sending side and at the bottom you have the receiver. Now the sender has a send window size of 5. ठीक है? So आपके पास, if you notice, you have some blue packets, then you have these white packets over here. So ये जो blue packets है, ये वो सारे packets हैं जिनकी acknowledgement receive हो चुकी है. So you've transmitted packet 0. ठीक है? So you've transmitted packet. Okay, I'll just reset. So at this point in time, आपने कोई packet transmit नहीं किया हुआ. So the window is starting from 0 up to 4. It has a size of 5. ठीक है? अब इस विंडो में दो चीजें हैं. एक तो बेस है which specifies कि जी आपका ये जो विंडो है ये शुरू कहाँ से हो रही है. ठीक है? That's called the base of the window. ठीक है? So this window is beginning from packet number 0. So the base has been set to 0. Achha. Now within this window you have something called the next sequence number, and that corresponds to what is the next packet that you're going to transmit within this window. We haven't transmitted any packet, so the next sequence number is also 0. Now go back and protocol may the interesting thing is that the receiver has a window size of 1 always. Okay? So receiver may you have a window size of 1 and the receiver is waiting to receive packet number 0. Okay? So when we click on send new, ठीक है, एक packet number 0 भेजा उसने, ठीक है जी, and ये packet number 0 receive हुआ, and you're sending the ACK back, which is ACK number 0, and as soon as this is received, ठीक है, now what happens is that the window slides forward by 1. ठीक है? So when the accuracy is received for 0, you were waiting for the ACK for 0, वो ठीक पहुंच गया, आपने window को एक slide forward कर दिया. So now the new base is moved to 1. Your next sequence number is also 1. You send the next packet. I'll just pause over here. So notice that the base remains as 1, but the next sequence number is now 2 because if you transmit a next packet, ठीक है, उसका sequence number क्या होगा? It's going to be 2. So I'll transmit that as well. ठीक है? So now I have packet number 1 and packet number 2 in flight. The base is still 1 because that is जहाँ से आपके पास unacknowledged packets शुरू हुए हैं, ठीक है? And the next sequence number has gone up to 3 because if I transmit a new packet, it's going to be packet number 3. Let's make this a bit faster. So ACK 1 वापस आया, the window slides forward. 2 वापस आया, the window slides forward. And notice that now what's happened is that your base has become 3. The next sequence number is also 3. And you have successfully received the ACKs for packet 0, 1, and 2, जो कि यहाँ पे blue में show हो रहे हैं. So जो successfully receive हो गए ACKs, वो सारे blue में show हो गए हैं. They have been done successfully. The next window is all over here, which is still of size 5. So you have a window of size 5 which is sliding forwards. Okay? So each time you send a new packet, हमने पास, now I try send something else, I can't. लेकिन जो ही ये packets आते जाएंगे, the window slides forward. Okay? So I can only send 5 outstanding packets. If I try to send the 6th one, I can't. ठीक है? लेकिन जो ही packets वो आते जाएंगे, it slides forward. ठीक है? And notice कि receiving side पे एक ही आपके पास window है. Right? So any questions so far?
Sir, इस केस में हमारे पास क्यूमुलेटिव एक्नॉलेजमेंट आती है ना, लेकिन यहाँ पे आप जो पैकेट ट्रांसमिट करें आपको उसकी एक्नॉलेजमेंट मिल रही है.
जी. So it's a very interesting thing and we'll see that now. Let's say मैंने 2 पैकेट्स भेजे, ठीक है, और मैं पॉज कर देता हूँ, ठीक है, और मैं क्या करता हूँ कि इस पैकेट को मैं किल कर देता हूँ, ये पैकेट इट गॉट लॉस्ट ऑन द वे, ठीक है. सो नोटिस रिसीवर जो है ना वो एक्सपेक्ट कर रहा है टू रिसीव पैकेट नंबर 0, और पैकेट नंबर 0 जो है ना रास्ते में इट गुम हो गया, एंड पैकेट नंबर 1 जो है ये उधर पहुंचता है तो इट्स सिंपली गोइंग टू डिस्कार्ड इट बिकॉज वो 0 के इंतजार में था, ठीक है, एंड उसको अगर उस सीक्वेंस नंबर के आगे कोई भी पैकेट मिलता है तो इट्स गोइंग टू डू नथिंग, ठीक है. अब नोटिस के बफर में 0 and 1 दोनों पड़े हुए हैं. जब टाइम आउट होगा तो जितने भी अनएक्नॉलेज्ड पैकेट्स बफर में पड़े हुए थे वो सारे के सारे दोबारा से रीट्रांसमिट हो जाएंगे. दैट्स व्हाई वी कॉल इट गो बैक एन. ठीक है? So when a timeout takes place, ठीक है, what happens is that whatever is unacknowledged in this window, वो सारे के सारे retransmit हो जाए, ठीक है? अब नोटिस के मैं एक नया भी भेज देता हूँ पैकेट, 0 सही पहुंच गया, ठीक है? इस पैकेट को मैं किल करता हूँ, ठीक है? अब ये 0 ठीक पहुंच गया. Once again 2 पहुंचने पे क्या होगा? It's still going to send back कि जी the correctly acknowledged one was 0. It's a cumulative act. On receiving something ahead of it, ठीक है? This particular implementation, I mean, in the previous case, it simply discarded it. Whether it discards it or sends back a 0, उसका effect एक ही है, because जब आपको यहाँ पे ये चीज मिलेगी, ठीक है, तो it's nothing is going to happen over here. So I would have thought it should have discarded that because it was expecting a 1. आपने 2 भेज दिया उसको, ठीक है, and like in the previous case, it should have simply discarded that 1. Now, if you resume, timeout होगा, उसके बाद ये दोबारा भेजेंगे, ठीक है? अब क्या हो रहा है कि 1 and 2 properly acknowledge हुए हैं, and 1 पे एक आगे स्लाइड होगा, 2 पे फिर ये आगे स्लाइड होगा, and it's going to go ahead, ठीक है? Now, let's say आपने 4 भेज दिए, ठीक है, and बीच में से आपने ये वाला जो है ना, इसको किल कर दिया, ठीक है? स्लाइड फॉरवर्ड, ठीक है, यहाँ पे दोबारा से whatever is received beyond this, it should have discarded this number 4, ठीक है? But even if it doesn't discard it, cumulative acts चल रही हैं. On receiving this, it still tells you कि अच्छा जी मुझे 4 तक ठीक मिल गए, मुझे 4 तक ठीक मिल गए, and that tells the sender कि अच्छा 4 तक इसको ठीक मिल गया है. वो उसको बफर ही करेगा, उसको कुछ नहीं करेगा उस पर्टिकुलर चीज को. It's going to wait for a timeout, and when that timeout happens, ठीक है, then when that timeout happens, what will happen is that whatever was there, whatever was transmitted and is still unacknowledged, all of that, you basically go back and you go back and retransmit all of those unacknowledged packets again. ये चारों जो है ना, ये फिर इकट्ठे आ जाएंगे. Okay, so very good question by Ali here. He says कि जी ये तो we're retransmitting multiple packets and dropping packets which have already got through, ठीक है, or you're retransmitting packets which have already got through, तो ये तो it's inefficient. It is inefficient, right? But the inefficiency is balanced by simplicity. And simplicity ये है कि आपके पास receiver पे एक ही size की window है. You're expecting a certain packet. If that comes through, you're going to slide the receiver window 1 forward. If that doesn't come through, ठीक है, तो फिर आप क्या करते हैं कि usually what the protocol says is that ये जो आप expect कर रहे हैं, इससे अगर कम sequence number के packets दोबारा आते हैं, तो उसमें आप acknowledge करते हैं कि what is the last highest sequence number that has already gone through successfully. Whereas अगर इसके ज़्यादा वाले आ रहे हैं, उनको आप discard करते जा रहे हैं. So your receiver window size is only size 1. It's very simple. If a timeout takes place, आप चुप करके जितने भी आप भेज चुके हैं, उन सबको दोबारा से retransmit कर देते हैं. So you don't have to worry about or track कि अच्छा कौन सा पैकेट पहुंच गया, कौन सा नहीं पहुंचा. इन selective काम आपने नहीं करना. You have a very simple protocol which has a certain transmit window size and a receive window size of only 1. ठीक है? So it's a very simple protocol. So notice के अगर आपने 3 भेजे, ठीक है? Now let's say that this got through, ठीक है? And this also got through, this also got through. ठीक है जी? And ये जो acts आ रही है ना, इनको मैं I'll kill the acts. ठीक है जी? I'll kill all of these X. Sender को नहीं पता चला कि receiver को कुछ भी मिला. अब receiver is now expecting packet number 3. Okay. अब टाइम आउट होगा तो क्या होगा? पैकेट नंबर 0, 1 and 2 दोबारा से आएंगे. ये पैकेट नंबर 3 एक्सपेक्ट कर रहा है बिकॉज 0, 1, 2 तो इसको ठीक मिल चुके हैं. ठीक है. So when the timeout takes place, these 3 packets are retransmitted, and notice that पहले पे it's going to then again say कि अच्छा जी मुझे 2 तक ठीक मिल गया. And ये जब इधर आएंगे तो ये भी इधर what will happen is that क्योंकि आप बता रहे हैं कि 2 तक ठीक मिल गया उसको, on getting that first one it's going to slide forward all the way to 3 because it knows कि अच्छा 2 तक तो उसको ठीक मिल गया है सारे. It's a cumulative act. So on receiving the first one, it's going to straight away jump 2 spaces and move your base to 3 because it knows that cumulatively 2 तक उसको ठीक मिल गया. Okay. Now, the question over here is that given a window size of 5, okay, and a receiver window of size 1, so you can have a scenario once again where agar suppose you had packet number 0 over here again, okay, so if you numbered them 0, 1, 2, 3, 4 and back to 0 again, you could have a scenario where you transmitted these 4 packets. They got through all successfully. So your receiving window size has gone to here, which is going to be packet number 0 now because I'm numbering 0, 1, 2, 3, 4, and 0. Okay? And then assume that each one of these acts got lost on the way. Okay? And notice that here 5 की बजाय यहाँ पे 0 numbering है. 0, 1, 2, 3, 4, then you're back to 0 again. You're looping back to 0 again. And अब timeout होगा, this is expecting packet number 0. 0, 1, 2, 3, 4 के बाद 0 है. ठीक है? And ये packet number 0, ये पिछला number 0 आया. ये expect कर रहा है अगला number 0. ठीक है? So on receiving this 0, if अगर numbering यहाँ पे दोबारा 0 से set start हो जाती, ठीक है? तो then फिर क्या होता? Then there would be a difference in what the receiver is expecting. It's expecting number 0, लेकिन it's expecting a new 0, the next packet. Whereas this is the previous 0. ठीक है? So अगर ये उसको accept कर लेते हैं इस packet को 0 को, so then of course you're in trouble because now what's happened is that transmitter ने तो packets repeat किए. Receiver is now accepting those packets because they are from a valid sequence number. Okay? So what does that tell us? If you have a sequence 0, 1, 2, 3, 4, you cannot loop back and then number them 0, 1, 2, 3, 4 because of this case over here, this use case that we've just described, because you will not be able to discern कि ये जो 0 है, ये पुराना 0 है या नया 0 है. So basically what we're saying here is that अगर आपके पास overlapping sequence numbers आते हैं between your transmitter and your receiver, तो फिर गड़बड़ होगी. So when you sort of transmit all 5 packets and all 5 of them are accepted, and if the acts get lost, ये जो sending window है ये आगे slide नहीं करेगी. That will remain stuck there. But the receiving window has slid this entire 5 packets and it's moved to here. So अब ये जो packet number है, this cannot overlap with these packet numbers that you have over here. ठीक है? That it cannot overlap. If it does overlap, then you have a problem. Is this clear? So with n bits, ठीक है? With n bits, I cannot have a window size. If I have a window size of let's say 2 to the power n, I cannot use that for my sequence numbers. I'll have to use sequence numbers such that there's no ambiguity. ठीक है? So इस केस में आपके पास sequence numbers कहाँ से शुरू कर सकते हैं? So अगर आपके पास 0, 1, 2, 3, 4 है, of window size of size 5, to make this unambiguous, this has to be packet number 5. ठीक है जी? तो ये unambiguous होगा. So I have to use sequence numbers which are at least one greater than my window size in order to ensure that I have no overlaps between the sending window and ये जो receiving window of size 1. Okay? Okay, so let's get back to here. So the sender can send up to n unacknowledged packets in the pipeline. The receiver can only send cumulative acts and doesn't act packets if there's a gap. Sender has a timer for the oldest unacknowledged packet. When the timer expires, it retransmits all unacknowledged packets. एक ये standard तरीका है which is called go back. एक दूसरा तरीका है which is called selective repeat. यहाँ पे you have the sender can have up to n unacknowledged packets. Once again, the receiver sends an individual ACK for each packet. So this time the receiver has a window which is the same size as the sender window, which is also of size n. And the sender maintains a timer for each unacknowledged packet. Okay? यहाँ पे you only have one timer for the oldest unacknowledged packet. यहाँ पे you have a timer for each unacknowledged packet. When that particular timer expires, you only selectively retransmit that packet only. ठीक है? So selective repeat में you have more complexity. ठीक है? उसमें आप ये कर रहे हैं कि what you're doing over here is that you individually acknowledge all correctly received packets. ठीक है? And then if a particular packet times out, आपको ACK नहीं मिली उसकी sending side पे, आप सिर्फ उसी वाले को दोबारा से भेज रहे हैं. And let's take a look at this in action. Okay. Right, so once again, sender पे window size 5 है, the base is 0, and the next sequence number is also 0. Receiver पे now you have a window size of 5, 0 to 4. ठीक है? You send one packet, you send another packet. ठीक है? इसका ACK आया, इसका ACK आया, and एक आगे slide करेंगे, एक आगे slide करेंगे. I can't send more, I'm sending all 5. ठीक है? And ये मिलने पे it's going to slide 1/4. So this is correct operation, perfect operation. अगर आपने ये भेजे, and notice के अब मैंने क्या किया कि this one over here got lost on the way, this one over here got lost on the way. ठीक है? अब इसके मिलने पे it's ACKing 0, इसके मिलने पे cumulative ACK नहीं है. 2 के ऊपर it's going to say ACK 2, 4 के ऊपर it's going to say ACK 4. ठीक है? And यहाँ पे जब ये सही पहुंच गया, which is at your base, ठीक है? So it's going to slide your window forward. अब जब ये acknowledgements 2 and 4 पहुंचे, वो base पे नहीं है, base वाली 1 है, तो उनको वो बफर में रखेगा कि अच्छा ये तो सही पहुंच गए हैं, ठीक है? लेकिन इसका ACK का भी इंतजार कर रहा है. ये इसके टाइमर खत्म हो गए हैं because these have been correctly received. लेकिन जब ये टाइम आउट होगा, एंड जब ये टाइम आउट होगा, तो सिर्फ सेलेक्टिवली पैकेट नंबर 1 एंड पैकेट नंबर 3 को दोबारा भेजेगा. Notice 2 and 4 have been acknowledged as received. So now you're selectively going to, when the timeout takes place for packet number 1, go back end में जब timeout होता है जितने भी आपके पास आउटस्टैंडिंग है वो सारे के सारे रीट्रांसमिट होंगे. इसमें सिर्फ जो आउटस्टैंडिंग है वही selectively रीट्रांसमिट होगा. एंड नोटिस के जब ये पहुंच गया और ये पहुंच गया तो contiguously 0, 1, 2, 3, 4 तक पहुंच गए. So your window is going to slide from 5 forwards. Your base is going to jump to 5. ठीक है, base because 1 and 3 पहुंचे थे लेकिन क्योंकि 2 and 4 भी already पहुंच चुके हैं, उसे ट्रैक रखा हुआ है. It slides that contiguous in one go all the way up to and the base is moved to 5. Okay. So selectively you transmit packets. If a packet is sort of lost on the way, ठीक है, अब यहाँ पे it's not sliding the receive window forward because it was expecting 5. Only once it gets 5, it's going to slide this forward. So it's going to buffer 6, 7, and 8 because वो correctly receive हो गए हैं. It sent the ACKs back. Transmitter भी buffer करेगा इनको. It knows that it's got 6, 7, 8 back. लेकिन 5 का ACK वापस नहीं मिला. जब ये टाइम आउट होगा तो सिर्फ पैकेट नंबर 5 सेलेक्टिवली दोबारा भेजा जाएगा. Okay, so it takes a while to time out. So once it times out, 5 दोबारा गया. And notice जब ये 5 hit करेगा इधर तो 6, 7 and 8 already वहां पे पहुंच चुके हैं. It's going to slide this कहां से? It's going to slide this starting from 9. So 9, 10, 11, 12, 13 पे ये विंडो स्लाइड हो जाएगी. तो जो ही हिट करेगा, ठीक है, एक्ट 5 की गई एंड बिकॉज 6, 7, 8 पहले एक्नॉलेज हो चुके हैं, रिसीव हो चुके हैं सक्सेसफुली, तो ये इट्स गोइंग टू स्लाइड दैट विंडो ऑल द वे 5 स्टेप्स. अब जब ये एक्ट इधर वापस आएगी, ठीक है, तो 5 एक्ट हुई, 6, 7, 8 ऑलरेडी हो चुकी थी. इसका मतलब है एवरीथिंग अप टू 8 इज नाउ सक्सेसफुली बीन एक्नॉलेजमेंट. इट्स गोइंग टू स्लाइड द विंडो फॉरवर्ड टू 9, 10, 11, 12, 13. Okay. Any questions here, जी? So notice कि it's more complex. आपको हर पैकेट के लिए अलग से टाइमर रखना है and receiving window में भी आपको उसी साइज की रखनी है जो सेंडर की है, and receiving window में भी जो भी पैकेट आपको आउट ऑफ सीक्वेंस मिल रहा है यहाँ पे उसको बफर किए जाना है until everything has arrived contiguously. Then you can jump forward and slide this receiving window forward. ठीक है. Now इस केस में आपके ख्याल में सीक्वेंस नंबर्स का और विंडो साइज का क्या रिलेशनशिप है? Any relationship that you can think of here. So think about the case. आपने ये सारे भेज दिए, ठीक है, and receiving side पे ये सक्सेस रिसीव हुए, the window has slided forward. But lo and behold, all the acts somehow किसी intermediate buffer में गए and उसने इनको खा लिया. ठीक है. अब ये दोबारा 0, 1, 2, 3, 4 टाइम आउट होंगे एंड रीट्रांसमिट होंगे. ठीक है. Whereas this here is expecting 5, 6, 7, 8. So if you looped back your sequence numbers and had 0, 1, 2, 3, 4 again over here, ठीक है, you would be in trouble because ये पिछला पैकेट आ रहा है, ठीक है, whereas this is expecting new packets over here. All of those previous ones have been received successfully. So for you to ensure that the protocol works properly and you are able to discern new packets from previous packets, none of these sequence numbers should overlap. So जो previous sequence numbers एक window में है, let's say आपने transmit किए and वो successfully receive हुए, लेकिन ACK stop हो गए, receiving window slide कर गई forward, sending window वहीं पे stuck है, ठीक है. So no number from here should be repeated in this entire window over here. So what does that mean? What constraint does that place? Anybody?
सर पैकेट नंबर रीस्टार्ट नहीं करेंगे
जी
मतलब सेम नेम नहीं देना दोबारा पैकेज तो रीस्टार्ट नहीं करेंगे कंटिन्यू करना है
हाँ, so for you to be able to discern कि अच्छा ये पुराने पैकेट्स हैं और नए नहीं है, तो ये जो नंबर्स हैं these should be distinct from these numbers over here. So इसका मतलब ये है कि आप यहाँ पे दोबारा रीस्टार्ट कर सकते हैं लेकिन इधर नहीं कर सकते. In other words, your sequence numbers have to be at least twice the size of your window, if not greater. तो अगर आपकी विंडो साइज जो है वो 4 की है, तो you need sequence numbers, you need 8 sequence numbers because 0 1 2 3 4 0 1 2 3 ठीक है इधर होंगे and then 4 5 6 7 होंगे and then you can go back to 0 again. So you need to have a window size which is at least half the size of your sequence numbers or smaller, तो फिर काम चलेगा. वरना इस किस्म के सिनेरियो में where packets आए, successfully receive हुए, packs गुम गए और ये retransmit कर रहा है और ये नए packets expect कर रहा है. So these old packets in the window here and these new numbers, sequence numbers, should not be overlapping. So for that to take place, your sequence numbers must be at least twice the size of your window or greater. क्या ख्याल है? Does that make sense? G. Because if you had a number 0, 1, 2, 3, 4 in here, any one of these, तो फिर जो पुराने पैकेट्स हैं उनको आप accept कर लेते as a new packet. Yeah. Okay. Any questions here, G? Right. So ये दो main pipeline protocols हैं. Go back in and selective repeat. You have a sending base, a next sequence number corresponding to the next packet that you're going to transmit. ये आपने transmit कर लिए. These have been transmitted but not yet acknowledged. These have been acknowledged, the green ones already. And जब आपके पास ये green सारे इकट्ठे हो जाएंगे, so then it's going to slide that window to here. ठीक है? So जितने green इकट्ठे होंगे from the left edge, from the sending base, वहां तक आपके पास your sending base is going to get extended on receiving these two green over here. अगर ये green आता है और ये नहीं आता है, it will still remain over here. ठीक है? So this is sort of in summary, आपके पास selective repeat में sender क्या कर रहा है, receiver क्या कर रहा है, and this is the case that you have over here. Now the dilemma, I've explained this with an example that suppose you had packets numbered 0, 1, 2, 3, and then 0, 1, 2 again, and your window size was 3 over here, and you sent 3 packets which were successfully received, okay? And acts bhi aapne wapas bheje. On receiving an act, this slides forward. On receiving the second one, this is going to slide forward. This packet over here is going to get dropped. There's no problem over here. But in this case, where think of it as a curtain between the transmitter and the sender. So the sender doesn't really know कि receiver पे क्या हुआ. You send back 3 packets, 1, 2, and 3, successfully receive हो गए. On receiving each one, this receiving window has slid one forward. ठीक है? And acts तीनों की तीनों drop हो गए. ठीक है? Now ये जो कि acts drop हो गए, time out हुआ, आपने packet number 0 retransmit किया. ये जो packet number 0 आपने retransmit किया, it appears in this window over here. So it is thinking of this packet number 0 जो कि पुराना packet था as a correct new packet. So oops, you have a problem. ठीक है? So the receiver, the relationship between sequence number and window size in order to avoid this problem is that you have to ensure that if your receiving window and has completely slid forward, ठीक है, on receiving all correct packets. So अब none of the sequence numbers over here belongs to the previous sequence numbers that you have over here, and that is only possible if your sequence numbers are at least twice or greater than your window size. Okay, so any questions here? Any questions? G. Any questions? No, window size plus one number nahi karenge. We're going to have numbering which is going to be twice the size of the window. ठीक है? So अगर window size आपका let's say size जो है ना आपका let's say 2 है, ठीक है? तो फिर आपका जो sequence numbers है ना वो क्या होंगे जी? वो कम से कम 0, 1 ये तो 2 विंडो साइज के लिए चाहिए आपको, लेकिन इससे डबल साइज यानी 3, 2 and 3 भी आपको चाहिए, बिकॉज नोटिस कि इस ये जो एग्जांपल है यहाँ पे, दिस इज शोइंग कि ट्रांसमिट साइड पे आपने 0, 1 and 2 भेजा, आपको इनकी एक्स वापस नहीं आई, लिहाजा ये 0, 1 and 2 पे फंसा हुआ है। रिसीविंग साइड पे ये पैकेट्स ठीक पहुंच गए तो ये 1 स्लाइड फॉरवर्ड हुआ, एक मजीद स्लाइड फॉरवर्ड हुआ, एक मजीद स्लाइड फॉरवर्ड हुआ, तो 0, 1, 2 is now slid to 3, 0, 1. ठीक है? So sending side पे it's still at 0, 1, 2. So this is going to time out and retransmit the old packet number 0. Now, if this 0 appears over here again, this is supposedly a new number 0. So you have a problem because this is transmitting the old packet. This is treating that one as a new packet. Okay? Because in this window, it's treating this 0 as a second new packet. जो भी आएगा. That can't be the case. So you have to, in order to discern between a new 0 and the old 0, a 0 cannot appear in this window over here. When you have this window fully slid forward, it can't appear over here. So उसका मतलब ये है कि जो आपके sequence numbers होंगे, ठीक है, they have to be at least, they have to span a range which is at least twice the size of the window. Because जब ये 0, 1, 2 पे गई, अब आगे देखें ये 3 की विंडो अगर यहाँ पे expand होती है, जो कि receiving side पे 3, 0, 1 पे, तो ये यहाँ पे आ रही है. So I cannot have a 0 again over here. ठीक है? So I need to have at least 6 numbers. 0, 1, 2, 3, 4, and 5. So तब जाके it's going to be unambiguous. Because if I had numbered them 3, 4, 5, ठीक है? Now, if I had these as 3, 4, 5, now when a 0 comes through, the transmitter knows कि अच्छा, the receiver knows that that 0 is not what I'm expecting. So it's going to discard that packet. ठीक है? So on receiving a 0 over here, उसको तो packet को तो discard करेगा, but it's going to send back an acknowledgement, ठीक है, for कि जी मुझे ठीक मिल गया है, ठीक है? So that will ensure that then this will know कि अच्छा 2 तक ठीक मिल गया है, so it's going to slide this to the next 3, 4, 5 पे. It's going to slide that forward. Because if it doesn't do that, तो फिर आपके पास ये time out करता रहेगा और ये transmit करता रहेगा, ये उसको discard करता रहेगा, and both of them are going to sort of stay deadlocked. Okay? So the window size has to be twice. It should span. The sequence numbers should span a range which is twice the window size. Okay, so the sequence numbers are 0, 1, 2, 1 and the size 2 hai, so you have a range which is 0, 1, 2, 3, twice that. And go back n ke liye it's window size plus 1. Yeah. Yes, you can use window size plus 1 for go back n because usme it's unambiguous. Because the receiver window is always of size 1 in go back n. तो गो बैक एंड में आपको द रिसीवर इज सेइंग मुझे ये चाहिए, अगर उससे कुछ पहले आ जाता है तो इट सेज कि अच्छा जी मुझे तो यही चाहिए, अगर उसके कुछ बाद आ जाता है तो इट सेज कि मुझे तो यही चाहिए, ठीक है। सो इट डिस्कार्ड्स एवरीथिंग जो कि आगे पीछे है, ठीक है जी। Okay, so this brings us to the great TCP protocol, okay, which is the workhorse of all of the internet. It's an amazing protocol if you think about its history. It was proposed way back in 1974 by Windsurf and Kahn, and abhi tak yani for the last 40 odd years, 45 years se bhi zyada, it has stood the test of time. It is still working. It is still the backbone of the transport layer. Wherever you have a connection-oriented, reliable byte stream service aapko chahiye, so this works. So notice that it's a protocol that has built in all of this robustness, that aapke paas multiple hops ke upar data aapne transmit karna hai between a sender and a receiver. So it has all of these principles that we've just discovered sort of built in, and that ensure that आपके पास अगर एक sender है और एक receiver है, point to point ये चलेगा. It's going to run on your end systems, and it's going to provide a reliable in-order byte stream to the application layer above. ठीक है? It's a pipeline protocol, which means that you have windows and you're going to transmit multiple packets one after the other, multiple segments as they're called in the transport layer, one after the other. ठीक है? And कितने segments आप भेजेंगे उसमें, the amazing thing is that it's sort of dynamically controlled by congestion, which is network conditions के आपके पास, as well as flow control, which means that कि आपका जो receiver है उसकी क्या capabilities हैं of handling the data transmitted by the sender. So if the receiver is slow, if it's पुराना receiver है, slow है, and you have a very fast transmitter, the network conditions are fine, even then you've got to throttle the sender so that the receiver does not get overwhelmed. ठीक है? ये ऐसे ही है कि आपके पास एक छोटी सी प्याली है और आप उसके ऊपर जो है ना पानी का बम्बा खोल दें तो इट्स गोइंग टू ओवरफ्लो. ठीक है? तो जो जिस रेट से आप ट्रांसमिट कर रहे हैं, दैट हैज टू बी कमेंसरेट विद द कैपेबिलिटीज ऑफ द रिसीवर ऑफ हैंडलिंग दैट. आपने नीचे एक बाल्टी रखी हुई है, एक ड्रम रखा हुआ है, ठीक है, आप बम्बा खोलते हैं तो पानी जो है भर जाता है, नो इश्यूज, नो प्रॉब्लम्स. लेकिन आपने एक प्याली रखी हुई है, ऊपर आपने एक बड़ा सा जो है ना टूटी खोल दी है, so what's going to happen is that it's going to overflow. So that is flow control, that you're controlling the throttling the rate of the sender because the receiver cannot handle that rate. And congestion control, as we talked about last time, is that you're slowing down the transmitter because the network is congested. Along the way, जो बीच में आपके पास routers हैं and जो आपके पास links हैं, वहाँ पे congestion है, and उसकी वजह से आपके पास the receiver is capable maybe, but you have to slow down because otherwise you are causing further congestion in the network. Okay? Now, it allows for full duplex data. So we use this term full duplex. What does full duplex mean? Anybody? Full duplex?
Transmit and receive at the same time?
Yes. Transmission and reception. You can transmit and receive at the same time. Okay? And so you have a bidirectional data flow, and जो आपके पास transport layer के chunks हैं, they're called segments. The transport layer protocol data units, that's the sort of correct term, PDUs. Protocol data units are called segments. So we've said, अच्छा जी, network layer पे जो आपके पास protocol data units हैं, we call them datagrams or we call them packets. Link layer पे जो आपके पास protocol data units हैं, we typically call them frames. ठीक है? And transport layer पे भी जो आपके पास protocol data units हैं, we call them datagrams or we call them segments. So but for TCP, the name that we typically use is transport layer segments. आपके पास एक फाइल है, आप उस फाइल को ब्रेक डाउन करेंगे into chunks which are called segments, ठीक है, and you have what is called a maximum segment size, MSS, maximum segment size, which is the maximum size chunk that you can transmit as one block in the transport layer, ठीक है. Now आपके पास जो RFCs हैं, these are multiple RFCs which have defined the TCP protocol. So notice कि TCP transport layer protocol है, IP जो है वो network layer protocol. But you often hear the terms TCP IP, ठीक है, as if it's one protocol. Technically these are two separate protocols. TCP is a transport layer protocol जो कि end to end layer 4 पे आपको reliable byte stream दे रहा है. IP is a network layer protocol जो कि hop by hop आपको datagrams को, packets को forward करके दूसरे end तक पहुंचा रहा है. IP is unreliable. It is best effort. Provides no guarantees. ठीक है? Can result in packets arriving out of order. ठीक है? Can lose packets. Can corrupt packets. All of that can happen there. But then the reliability is built into TCP end-to-end protocol है, जो कि packets को या segments को sequence करेगा, इनको sort of यानी it'll keep track of कौन सी चीज पहुंची है, कौन सी चीज नहीं पहुंची है. It will slow down or accelerate the transmission rate based upon the network conditions or the end conditions, and it will provide the same file जो कि आपने transmit की at the receiving side. In other words, it provides a reliable in-order byte stream service to the application layer protocol above it. ठीक है? Now, how does it do that? We will come to the details of how it does that, but we just want to look at the segment header at the moment. Once again, ये 4 bytes या 32 bits के आपके पास एक particular row है, and notice that this is packet number 0 and this is bit number 0 and bit number 31. The next row is going to be bit number 32, say number 63, 64, so 95, and so on. So instead of showing one long packet, just like we've discussed before, the convention is that you show the packet in this form where you have multiple rows, but in reality you have one long sequence of bits which make up your particular packet. So यहाँ पे, in this diagram, you've arranged this into 32-bit words. So you have a 16-bit source port number, a 16-bit destination port number. So with 16 bits, you can have 2 to the power 16, which is 65,536 different source port numbers and the same destination port numbers. You have a 32-bit sequence number. Now, this sequence number is a number which is counting the number of bytes in the data. ठीक है? So amazingly ये है कि आपके पास जो data है itself, वो that is multiple bytes. ठीक है? लेकिन जो you number the data in terms of byte number. ठीक है? And जो पहले byte का number है उसको आप यहाँ पे sequence number में डालते हैं. ठीक है? So the interesting thing is कि अभी तक we've seen कि you're transmitting packet number 0 and packet number 1 and packet number 2. That's how we discussed all of these protocols so far. यहाँ पे what we're saying is कि जो sequence number है, let's say आप पहला packet भेज रहे हैं and हमने पहले packet के पहले byte का एक number रखा. Let's say हमने number 0 रख दिया. And this packet contains data which is 100 bytes. So what we'll do in TCP is we're going to provide a sequence number 0 for the first packet, which is of length 100 bytes. अब जब अगला segment हम भेजेंगे, तो उसमें हम sequence number 100 लिखेंगे, because that's the byte number of the first byte of the next sequence, of the next segment. ठीक है जी? Is this clear? Sequence number essentially is equal to the byte number of the first byte in the segment. ठीक है? बाइट नंबर ऑफ द फर्स्ट बाइट. बेसिकली आपने बाइट्स को नंबर कर दिया. अगर आपके पास लेट्स से you're transmitting 200 bytes and they're numbered from 0 to 199. तो सीक्वेंस नंबर लेट्स से पहले बाइट का 0 है, तो यहाँ पे हम सीक्वेंस नंबर 0 से शुरू करेंगे. अगला जो सेगमेंट है that contains data starting from byte number 200 to let's say 250. 50 बाइट्स आप 51 बाइट्स 51 बाइट्स आप सेकंड सेगमेंट में भेज रहे हैं, numbered from 200 to 250. Sequence number is going to be 200, which corresponds to the first byte number of the segment data that you have in this particular segment. Okay. So we'll come to these further details inshallah in the next lecture. So any questions so far? Any questions from today's lecture?
सर आपने जो सीक्वेंस नंबर्स की एक बात की थी कि सीक्वेंस नंबर शुड बी ग्रेटर देन और इक्वल टू 2 times द विंडो साइज.
जी
सर वो सिलेक्टिव रिपीट के केस में या फिर वो गो बैक एन के केस में या दोनों पे अप्लाई होता है?
वो सिलेक्टिव रिपीट के केस में है, बिकॉज आपका विंडो साइज ट्रांसमीटर एंड रिसीवर का एक ही साइज है, व्हिच इज साइज n सपोज. ठीक है, तो अगर आपका साइज n है, sequence numbers should span the range at least of 2n or greater. ठीक है, अगर आप go back n इस्तेमाल कर रहे हैं तो वहां पे आपके रिसीवर का साइज एक ही है, साइज 1 है, तो वहां पे you should span the range of n plus 1 or greater. ठीक है, so go back n में you need only to span n plus 1 or greater. ठीक है, so basically होना ये चाहिए कि जो अगर आप ट्रांसमिशन विंडो को देखें एंड रिसीविंग विंडो को देखें एंड आप यूज केस ये बनाएं कि ट्रांसमिशन विंडो ने सारे पैकेट्स भेज दिए, ठीक है, एंड एक्नॉलेजमेंट जो है ना वो आपके पास गुम गई. ठीक है, एक्नॉलेजमेंट सारे गुम गए. सो वर्क इट आउट कि एक्नॉलेजमेंट्स अगर सारे गुम जाते हैं, ठीक है, तो देन वुड इट बी n plus 1 or 2n? Just work it out. कि go back n के केस में work that same scenario again कि acknowledgements सारे गुम जाते हैं, तो then you have to make sure that let's say receiving side पे you will have advanced by n. ठीक है, तो आप कहाँ पे खड़े होंगे, and as long as अब ट्रांसमीटर उन पैकेट्स को दोबारा से go back n करके रीट्रांसमिट करेगा जब, ठीक है, so there should be no ambiguity. ठीक है, so just work it out that should that be n plus 1 or that should that be 2n or greater as well in that case as well. ये जरा सोच लें, just think about this.
Right, sir.
Okay?
Thank you.
Okay, so we will stop over here inshallah and we'll see you all on Friday morning inshallah. Allah Hafiz.